Hi, fifth graders, it's Miss Boniface. We are moving on to Unit 7. We'll be starting with the first one, exponential notation. And I want you to take a look at that first word, exponential. Think about what the base word of that would be. I hope you're picking out the word exponent. And that's something that we've talked about already this year, so hopefully we have some background knowledge that'll help us get through the lessons. We want to start off with standard notation. And standard notation is really just a fancy way of saying all the basic numbers that we usually see or write in everyday situations. They have the place values and then also the digits 0 through 9. All right, so if I were to write the number 211, I just wrote a number in standard notation. It's just the plain Jane way of writing a number. Exponential notation, on the other hand, is the shorthand way to write repeated factor expressions. Exponential notation has two parts. It's the base and then the exponent. The exponent is written just above and to the right of the base. So right here I have 4, and that would be read to the third. See the small 3 up there? The 4 is the base and the 3 is the exponent. All right, so the exponent tells how many times the base is used as a factor. 4 to the third is really just the shorthand way of writing 4 times 4 times 4. We have them 3 times. The exponent tells how many of them you'll need. So 4 times 4 times 4. Which one of these is true? Is 4 to the third equal to 12? Or is 4 to the third equal to 64? All right, well, let's write that the long way, writing all the factors out. So 4 times 4 times 4. And the reason I knew how to do that is because it's right here. My base number is 4, the factor I'll be multiplying. And the exponent told me that I needed 3 of them, 4 3 times. So 4 times 4 times 4. Let's solve that now. We know our multiplication, so 4 times 4 is, I hope you're thinking 16. And we need to multiply it by that last 4. 16 times 4. And when you multiply that, you should get 64 as your answer. All right, explain your answer. Why is it not 4 to the third equaling 12? Why is that false? Well, I think what they did here is they did 4 times 3 and got their answer of 12. And really 4 to the third means 4 times 4 times 4. All right, I hope that makes sense. On to our chart here. We've got a whole column of exponential notation. The next column is base, exponent, repeated factors, and then standard notation. Right, so how we would write that number just plain. So they have here 5 to the fourth. The base is the 5. The exponent is that tiny number up in the right, and it's the 4. Writing it as a repeated factor is 5 times 5 times 5 times 5. We have 4 of them because that's what the exponent tells us. So let's double check their work and make sure that it really does equal 625. We know that 5 times 5 is, yes, 25. We need to multiply it again. 25 times 5. Whenever I multiply 25s, I always think of the quarters. Right? And how many quarters are in a dollar? Well, 25 cents is 1 quarter. There's 4, so that would be 100, or your whole dollar. Then I need 1 more because I have 5. So 25 times 5 should equal 125. So here I did 1, 2 to get 25, 3. I need to multiply 125 by my last factor of 5. Go ahead and pause me to solve that for yourself. 125 times 5. Go ahead. All right, I hope that you got 625. That is what 5 to the fourth equals. All right, we'll move on to the next one. Now we have to fill in the chart. They left 4 blank spots for us to solve. but they did help us out a little bit here. They gave us the repeated factors. So 6 times 6 times 6 times 6. We should probably start with the base. The base we should be able to pick out as well is a 6. The exponent, how many 6's do we have there? Well, 4 again, right? Once we have the base and the exponent, exponential notation is a piece of cake. 6, and I'll try to make my 4 small, to the 4th. Now I need to multiply. All right, so 6 times 6, we know our doubles, 36. 36 times 6. Go ahead and pause me and solve that for yourself. 36 times 6. I hope you got the same answer as me, 216. Then we need to multiply it one more time to get that last 6 in there. 216 times 6. And that should equal, go ahead and pause me again if you need to solve that. It should equal 1,296. All right, so in other words, 6 to the 4th equals 1,296. What I'm going to have you do now is the last one to check your understanding. Okay, so we just solved the one before it by doing it together. Take a look at the repeated factors that they gave you. 9 times 9. I want you to find the base, the exponent, then you can write it in exponential notation, then solve it for your standard notation. Write that on a blank piece of paper and bring it with you to math tomorrow, okay? Each problem below has a mistake. We need to find that mistake and tell what it is. Then solve the problem. Sounds easy enough. Let's go for it. 5 squared. Might have forgot to mention that 2 as the exponent, we call that a square. Okay, you can either say 5 squared or you can say 5 to the 2nd. That's okay too. So 5 squared equals 5 times 2, and that equals 10. Find the mistake. Okay. It's right here. They really didn't do what they needed to. 5 squared means 5 times 5. What they did, they multiplied the base times the exponent, not what we need to do. So what I filled in up there on the mistake is that they multiplied the base and the exponent together. Under here on the correct solution line, we want to solve that now. 5 squared really means is what is 5 times 5? I've got 2 5's there. And we all know that. It is 25. All right, simple as that. We solved it. Found their mistake and we solved the problem. Let's go on to the next one. How would you read this? Sorry about that. How would you read this in exponential notation? 6 to the 3rd, right? And another trick with the 3 is you can say cubed. How we said squared up here with the 2, the 3 you can say cubed, or you can say 6 to the 3rd. It's up to you. Right? We need to figure out what they did wrong. They have 3 times 3 times 3 times 3 times 3 times 3 equaling 729. I hope right now what's sticking out to you are these 3's right here. That does not match our base of 6. Huh. So what they did was they totally flip-flopped. They used the exponent as the factor, and they used the base as the exponent. So what I filled in there for the mistake that they made was they flip-flopped the base and the exponent. What we really wanted was the base, the factor here being 6, and we wanted it 3 times. So that's why I drew down here 6 times 6 times 6. So now we need to solve that to get our right solution. 6 times 6 we all know is 36. And then the next step, I hope you're thinking right now, is that we need to multiply 36 by 6. To get our answer, we'll put it up here on the line. Should be 216. Okay, I hope this is making sense to you. If it's not, you can ask me or Mrs. Bjork some questions that you had about it when you come to class tomorrow, okay? Also, for the last one, I'm going to have you guys do that on your own, on that blank sheet of paper that you already have out and working on. I want you to find the mistake that they made in the last one. So that what they have is 10 to the 4th, and they said it equals 10 plus 10 plus 10 plus 10, and that equals 40. Find their mistake, and then give us the correct solution. And then you'll be all set to have your 2 problems ready to go for math. All right, good luck.